Hello and welcome to COP 4708. In this lecture we'll continue learning about the entities in the system and how we can create a model that represent the relation between these entities. In the last lectures we learned about the entities that we need to track in the system, which will be the nucleus of our database creation. Those entities can be expressed in relations or what we call tables. Each entity has a set of characteristics or attributes that is associated with it. Some of these attributes can determine other attributes in the relation, or in other words, they have relationship with each other. Those attributes depend on the determinant through functional dependencies. Once we define the attributes of the entity, we need to identify the functional dependencies of the attributes. Some of these attributes are considered as the magic key that opens the box of the data for us, which is called, and if we can't recognize any attributes that can do that for us, we have to make our own key, which is called at that point a surrogate key. The key also important in connecting different entities together. Using that primary key in a different table will make it a foreign key to that second table. In this session, we will learn how to create model or what we call a blueprint for those relations before the implementation. A data model is a plan or a blueprint for a data. The data model is more generalized and abstract than a database design. It is the same concept as building a house, where you have to develop a model or a blueprint for that house before you start the build. In the conceptual model, you will have the ability to make changes, add or delete, but once the house being built, it's not easy to make these changes, and the same applies for the database. Once you make the design, it's hard to make changes because that will ruin or that will affect other tables and relations in the design. The entity relationship model is a set of concepts and graphical symbols that can be used to create the conceptual schema. To create the model, we need to understand the entities involved and their relationship. The entity relationship model has evolved from the original model that was suggested by Peter Chen in 1976 to other models such as IDF1 by DoD military. We have, IDF 1X or from 1 to 3 or more for the DoD military in 1993, and the UML model in 1995. Now remember, the entity is something that you need to track in the system. If you can identify a collection of entities of a given type, such as plane, car, employee, customer, order, then this could be called entity class. The occurrence of a particular entity of the entity class, such as Boeing 747, is an instance of a plane, which is called an entity instance. There are usually many instances of an entity in the entity class. Example of look at some of the examples in the instance in a car class. The characteristics of an entity is called attributes. All entity instances of a given entity class have the same attributes, but vary in the values of those attributes. We can represent the attributes in the data model with ellipses or as a new data modeling product with a rectangular form. This figure represents attributes of an employee, the attributes being represented by ellipses. Now imagine if you have 15 attributes or 10 entities, what do you think the figure would look like? That's why a newer representation being introduced, which is the rectangular form of representation. This figure shows the attributes in an entity in a rectangle form. Identifiers are attributes that name or identify entity instances. The identifier of an entity instance consists of one or more of the entity's attribute. Composite identifier identifies that consist of two or more attributes that identify the data model. The identifiers in the model will become a key in the database design. Identifier for the attribute that identifies the other data, which will be the primary key or the candidate key in the design. This figure shows an example of the different ways that you can display entity attributes in a data model. You can either show all attributes, you can show the relation name with the identifier only, or you can show the entity with no attributes. Entities can be associated with one another in a relationship. If the associations were among entity classes, it will be called relationship classes. And if the association were among entity instances, it will be called relationship instances. A relation class can involve two or more entity classes. Again, this is something that we have to understand on the model level, so you'll understand the different relationships between the entities that you will identify in the system, and from there you can convert that into design later on. Now, the degree of relationship is the number of entity classes in the relationship. The two entities have a binary relationship, while three entities has a ternary relationship, which is degree of 3. So each which is a binary, or three entities which is ternary. This figure shows an example relationship such as the relationship between skill, and another example of a ternary relationship such as client, project, and architect. Since we are talking about relationships, we have to mention cardinality, which means the count. And we talked about that briefly in the first session, or in the introduction to database, where we talked about the different relationships that you will be experiencing during this semester, the database management system. Usually, this count is expressed as a number. The relationship between the entities can be identified into two types: maximum cardinality or minimum cardinality. The maximum cardinality is the maximum number of entity instances that can participate in a relationship, while the minimum cardinality is the minimum number of entity instances that must participate in a relationship. So the minimum, they must participate; the maximum, they can participate, and this is the difference between the maximum and the minimum. There are three types of the maximum cardinality, and again, this is what we mentioned briefly in the lecture, in the chapter 1 lecture. We have a one-to-one relationship, one-to-many relationship, and many-to-many relationship. This figure shows different examples of maximum cardinality. The employee to badge is considered as a one-to-one relationship, while the employee to a computer is considered as a one-to-many relationship. The employee might have a desktop and a laptop, so it's one employee to many computers. Actually, the employee can work on any computer in the company, so we consider a relation of one-to-many in this situation or between these entities. A many-to-many relationship is an example of the employee with many skills. Each employee has many skills. Many employees has many skills or different skills. The entity, the relationship between the two entities can be a parent-child relationship, which is one-to-many. The entity on one side of the relationship is called the parent, while the entity on the many side is called the child entity. This figure shows an example of a parent-child relationship, the employee computer, and being represented here in rectangular shape of relationship or model. We have entity called employee with identifier called employee ID, and I have the attributes name, phone, email, and hiring date, while on the other side I have an entity computer which being identified by social and we have the attributes model, date of purchase, and operating system. This is a relation one-to-many. Another relation that we can identify is has a relationship. In this case, each entity instance has a relationship with another entity instance. And we can say that an employee has one or more computers. So either can be identified, or we can say it as parent-child, or has a relationship. Parent-child relationship, or has a relationship. For the minimum cardinality, which is the minimum number of entity instances that must participate in a relationship, minimums are generally stated as either 0 or 1. So if the instances or the number is 0, then participation in the relationship by the entity is optional. So no entity instance must participate in the relationship. If it's 1, then participation in the relationship by the entity is mandatory, and at least one entity instance must participate in the relationship. So in the minimum cardinality, remember that we have either 0 or 1. 0 for optional relationship, 1 for mandatory relationship, must relationship. We will see an example in the following slide how we can represent that in a graph. If it's a 0, it will be oval. If it's 1, it's vertical hash mark. Vertical hash mark. So if you see an oval, then the entity is optional, and if you see a vertical hash mark, then the entity is mandatory. Again, look at the line here, and as you can see here, it's mandatory to mandatory relationship. one-to-one, mandatory to mandatory. So the one-to-one represent the maximum cardinality, while the dashes here represent the minimum cardinality, which is mandatory to mandatory representation or relationship. We have here the oval, and that represents optional to optional relationship. The third situation is optional to mandatory, and we see on this side the oval, while on this side the dash line or mark. Another way to define that is what we call the ID dependent entity, which is an entity child whose identifier includes the identifier of another entity parent. So a child depends on the parent. That's why we say identity dependent entity. Usually the ID dependent entity is a logical extension or subunit of the parent. For example, building apartment. So the apartment is a child entity in the building that has or that depends on the building. If there is no building, there is no apartment. Printing and print. We will not have a print unless we have printing. So the print is considered as a child entity that's dependent on the parent painting. So painting and print are a child dependent. The minimum cardinality from the ID dependent entity to the parent is always 1. Those are examples of ID dependent entity: the building and the apartment, the painting and the print, the patient and the exam. If there was no patient, there is no exam needed. So the exam here depends on the existence of a patient. That's why we consider that as ID dependent. If you look at these examples, you can see the relationship being identified as one to many, mandatory to mandatory, one to many, mandatory to optional, one to many, mandatory to optional. Some of these entities are weak entity. The weak entity is the entity that existence depends upon another entity. All ID dependent entities are considered weak. Example of the exam and the patient, you'll understand that the exam is a weak entity because it depends on the existence of the patient. So if the patient does not exist, that entity will not exist. But there are also non-ID dependent weak entities. The identifier of the parent does not appear in the identifier of the weak child entity. This is an example of a weak entity. The model of the manufacturer, where we have the manufacturer model for a car. We have the description of the car, we have the number of passengers, we have the, and then for the information about number, color, date manufactured, cost, sales price, and date sold. The auto is a weak entity because the existence of the VIN depends on the manufacturer model. If we don't have a new model, we will not have a car that has these attributes. To understand that, we created what's called a dashed line that indicates a weak relationship between the two entities. Also, we can identify what's called a subtype entity, which is a special case of the supertype entity. For example, we have student, we have undergraduate student or graduate student. So the supertype contains all common attributes, while the subtype contains specific attributes. We can consider the student in this case as a supertype, while the undergraduate as a subtype, the graduate as a subtype. The supertype may have a discriminator attribute that indicates the subtype. So under the student as a supertype entity, we can include one of the attributes as undergraduate or graduate to indicate the subtype entity and to connect to the attributes of undergraduate. This is an example of subtypes with a discriminator. We have the patient, but we have a subtype male and female. So the discriminator here was the sex, and we had to create two separate subtype entities that represent the patient. The reason for that, the exam or the exams needed for the female are different from the exams needed for the male. Females have pap smear, while the male has the PSA score. The subtypes entities might be exclusive or inclusive. If subtypes are exclusive, one supertype relates to at most one subtype. If subtypes are inclusive, then one supertype can relate to one or more subtypes. Let's see an example. For example, if we have an employee, that employee could be a manager or a database admin. So that's an exclusive relation where the employee can be manager or database admin, but not both. While in the inclusive, actually the employee can be database admin or both. That's an example of a subtype exclusive or inclusive entity. One of the relations that we can identify between the subtypes is called is-a relationship. For example, the relationship containing supertypes and subtypes such as, or is a relationship such as the Boeing 747 is a plane. So the Boeing 747 as a subtype entity is a plane. That's a supertype entity, and that's how there is a relationship being created. The identifier of the supertype and all of its subtypes must be identical. For example, the employee ID supertype is the same for the manager. As we recognized weak entities, we can recognize strong entity pattern. A one-to-one strong entity relationship, if the input from the other entities, then we can consider that as a strong entity. For example, the club and the locker. Locker can stand alone with the locker number, locker room, and locker size in any place. whether it's a club, whether it's a school, whether it's any other place. So a locker is a strong entity that can stand alone and can be connected to any parent or any other entity. One-to-many relationship, the company departments, where we have a company that has different departments or many departments. The department is a strong entity that can stand alone. We have departments in a company, we have departments in a institution, educational institution, we have department in organizational, governmental organization. In any place we have different departments, so the entity department can be a strong entity that can stand alone. This is basically what I just said. A strong entity with a many-to-many relationship, like company and parts. So every part must have a company as a supplier, but every company need not to supply a part. So actually the part can stand alone as the strong entity with many-to-many relationship. We'll stop here and we'll continue next session with chapter 5 part 2. Thank you.